Hi, everyone, and welcome to the third episode of our Databases for AI series. My name is Emily Bayuk. I'm a security engineer at AWS, and let us know where you're joining from in the chat today. So, I'll be monitoring the chat throughout this episode. Because we're doing it live, I can get the opportunity to share your comments on screen throughout this episode. So, what are we going to be talking about today? Maybe you've heard about graph powered agents, or maybe you haven't. And in either case, you probably should be using them. And this episode will help you figure out if graph is right for your agentic use case. So, like I said, this is our third episode. In episode 1 last week, we talked about vector databases versus graph databases for Gen AI agents. And then yesterday, we actually went ahead and built a GraphRag powered AI agent. And I must say, our co-host yesterday, Melissa, did an amazing job walking us through how to build a GraphRag powered AI agent. I know I learned a lot, and I didn't realize it would only take us less than 60 minutes. So if you're interested in viewing the first 2 episodes of the series, I highly recommend you watch the replays, and our chat moderators will be putting the links in the chat. Plus, if you're on YouTube, you can also find the chat links in the description. So, I'm also joined today by Melissa, who I'm going to be adding to the stage. Hi, Melissa. Welcome, welcome, welcome. Why don't you introduce yourself to the audience?
Yep. Thanks, Emily, for having me. Hi, everyone. My name's Melissa. I am a Neptune specialist solutions architect here at AWS. So I work with everything Neptune and graph related.
Yes. So, Melissa is our Neptune and graph expert. So excited to have you on. So, let's talk more about what we're talking about today. And also, I'm just looking at the chat now. I'm seeing a lot of people from all over, some from Canada, India, another Canada person. Oh, hi, Lauren from Jersey City. Nice. So keep the comments coming throughout the show. Like I said, we're doing this live. And if you have questions, this is the perfect time to ask our Neptune and graph expert, Melissa. So, what are we talking about today? So, this episode is for you if you feel like you're hearing about knowledge graphs, but don't know if they actually apply to what you're building. And Melissa and I are going to be sharing concrete examples to help you understand where graphs actually matter and whether your use case is one of them. So, similar to yesterday's episode, we're going to be talking a lot about GraphRag. And Melissa, can you help clarify for our audience members what exactly is GraphRag? When would they use graph versus regular rag?
Yes. So GraphRag is a very similar architectural pattern to a standard vector RAG solution where you have your source documents, you're going to chunk them up somehow, generate embeddings for the corresponding chunks, store them in your vector store. And then when you have an end user coming in to ask a question, you're really using semantic search in order to surface the most semantically similar chunks to the input question. And I think for a lot of use cases, taking a standard vector RAG approach like that can be a really great way to kind of implement that question answering flow. Situations where I think that standard vector RAG flow kind of misses context are going to be situations where the questions that you ask will require additional information to answer the question that is not necessarily semantically similar. So, for example, in yesterday's episode and last week's episode as well, the common example use case that we've been talking about is kind of how example corp sales prospects are going to be affected by the release of this brand new product. Now, a question like how are sales going to be impacted by XYZ, you can already start to think like if I was a human being trying to answer that question, there's a lot of different data sources that I would probably need to pull in order for me to come to a conclusion, like a complete conclusion. Versus if you were just asking me a question like, what is the latest version of this widget product? That's a pretty straightforward question that could probably be answered by like a single chunk or a single document. And so where GraphRag really makes the difference is that it's powered by a graph. So that graph, really its core purpose is to kind of connect different entities that are mentioned within those different chunks, connect them together. And the entity to entity relationships is really what's going to help us surface additional relevant information that might not be semantically similar to the original question. And so I think a really big part of today's theme is not just focusing solely on GraphRag, but thinking about situations and use cases where adding a graph just in general can help improve context, relevance, and insights for whatever use case that you're trying to solve. And so today's use cases, we're going to be talking about a variety of different ones across different industries, looking some situations at GraphRag, some situations we're looking at just graphs. But overall, I think our theme for today is talking about graphs. How do we know when we would want a graph? What is a graph good for? And kind of where do agents come in the picture to make graphs more easily accessible to an end user?
Exactly. Yeah. Thank you so much for that great overview of GraphRag, what it is, and so excited to help the audience answer two main questions, hopefully by the end of this episode. You might be thinking, what are some use cases of GraphRag, and does GraphRag work for my use case? And like Melissa said, this is what we're going to be talking about during today's episode. So let's dive into what are these three use cases that Melissa and I are going to be talking about. So the first one, we'll start with security incident response. Then we'll talk about fraud investigations. And lastly, we'll wrap up the session with an example all about customer account intelligence. And throughout this episode, we'll also have fun trivia, kind of like knowledge checks after each example. So definitely stay tuned if you want to come and test your knowledge. And at the very end, there's a leaderboard. So you get like brownie points and bragging rights if you are one of our top 5, I think it shows. But we'll see. We'll see who comes in first. So it'll be good. It'll be good. All right. So let's dive into our first use case of GraphRag. And like Melissa said before, GraphRag is really all about relationships. And Melissa, as a security engineer, I would say so is security. So I'm really excited about this first use case that we're going to be talking about. So, in security incident response, when an account is compromised, we'll ask ourselves, okay, like what is the blast radius, or what can this compromised account access? And that's where GraphRag really comes in handy. So, going back to the idea of GraphRag and security being about relationships and paths, in this GraphRag use case, we need to figure out like who can access what and how security events propagate. So, let's take an AWS example and view this from an AWS standpoint. Let's say a malicious actor now has access to one of my IAM roles. So, IAM, or Identity and Access Management, is an AWS service that really lets you securely manage access to AWS resources. So, in this case, if an actor has access to one of my roles, that role can grant permissions. And that means that the actor can then grant themselves permission to access additional resources. So, like, for example, we could say now the actor's like, haha, I can now have read write capabilities in S3. And that's not good for us. But I guess if you're the actor, now you're pretty excited. But so now we have this relationship, and it's the relationship between this role, permissions, and resources. I know this has been pretty theoretical so far, but Melissa, I think it'll be a great idea if we show the audience like a real life use case. And I think you have one about how Wiz built a cloud security platform by modeling security graph data on Neptune. Is that right?
Yeah, absolutely. So the general use case that you're describing, Emily, is absolutely a very common use case that we see for graphs, and it makes a lot of sense. So security graphs in general, I would say, are all about modeling the different resources in your system as nodes, and then you'll have relationships between those respective nodes to represent how certain resources can interact with each other or even connect to each other. And so Wiz is a really great example of the security graph use case because they essentially do model the different AWS resources or just resources in general in your cloud environment and kind of stitching together a picture of how all those different resources can interact. And this is really helpful when you are trying to do some detection of a security breach, or you're looking for potential entry points that attackers might try to target first, right? Because if you've got, let's say we've got a ton of EC2 instances and a number of them have varying security groups with different security group rules, how do you know which EC2 instances to start looking into first in order to like figure out which ones to shut down, right? So you're going to want to see, well, if someone was able to, let's say, access a particular EC2 instance, well, what other resources does that EC2 instance have access to? And for those resources, what do they have access to? Right? So you can kind of build out this chain of potential attack vectors and paths, right, that someone could potentially access. And so using that knowledge of those potential chains can help you better prioritize which EC2 instances in this example that you should be trying to fix first.
Yeah.
I would, yeah.
And I love that you mentioned prioritization. And I feel like in security, it's all about prioritization and like, okay, what do we need to patch first? What do we need to investigate first? And having that prioritization aspect, at least from a security engineer standpoint, is super helpful.
Absolutely, because I feel like you're always going to have some number of vulnerabilities at some time. And it's not really realistic to be like, okay, let's attack all of them today and fix everything in like an hour. So having that prioritization is really helpful in helping you figure out like what do we need to get done first in order to create a secure environment.
Exactly. Like, I'm just picturing, like, I'm not like an octopus with like a million computers around and like just scrambling when something happens. So awesome. I love that. And also, I do want to call out you're getting some love with the plushie behind you.
Yes.
So not related to AWS, but
Yes. Thank you, William. Yeah, the LeChonk is in the corner. He has a nice little
yes.
squishy beanbag.
And we were talking about this yesterday, how your streaming setup from episode 1 to now is just we've turned Melissa into a streamer,
Yeah.
everyone. So we're
Yes.
so excited about that.
Yes.
All right. So now that we covered our first use case, let's dive into some trivia to test our knowledge. So right now I'm sharing my screen. We are going to be doing trivia. If you want to scan the QR code, or you can also join using the link in the bottom corner of the screen. So either one, we'll let the participants, the viewers, start trickling in. There is a delay from us streaming, just a heads up, everyone. And if you are joining, um, if you're watching this on replay and you're not live, unfortunately, this link will not work. But for everyone joining us today live, the link will work. And definitely join, test your knowledge. We'll be having a couple of questions throughout this episode. So, Melissa, while we're waiting for everyone to join, I'm kind of curious, like, how did you start your cloud career? How did you end up at Amazon? Like, I'd love to hear your career journey as we're waiting.
Yeah, absolutely. So I first came to AWS through a program called AWS Tech U, which is a 6-month program designed to on-ramp new grads into kind of like a cloud architect or solutions architect role. And so I was a generalist SA for the first 2 years that I was at AWS. And during that time, Neptune had just come out in 2018. And so it had been out for a year. It was still a relatively new service. I had some customers that were asking questions about it, and at the time, I was like, I don't know what graph is. It seems like such a niche database. What do I do with this? So I ended up spending some time learning about Neptune, and this is like several years ago now. And I just thought it was really cool. Like connected data, especially when we get to graph visualizations, which we will see shortly a little bit later on into today's stream. It's super cool being able to see all those different connections. And it's just a totally different way of viewing your data. Like I feel like we always see data in terms of like tables, just relational tables, or even if we're talking about other NoSQL options like key value stores, it's still kind of tabular when you look at it versus with the graph. It really brings to light all the connections that you could have in your data that aren't immediately obvious if you're just looking at it from a table format. And so that really kind of just sparked my interest. And then I eventually moved to the Neptune team because I just wanted to work with graphs all the time. And that's how I got here. So yeah.
And that's why you're here today. Nice. I love it. Well, thank you. I love hearing about your journey and also like how you thought it was so niche to begin with, and then it's so visual and like cool, and you just you went with it. So love it. All right, so we're going to get started now with trivia. Also, folks, feel free to join. If you didn't join already, the QR code will remain up throughout the trivia session, so you can join anytime during the live stream. So, all right, let's get started. So our first question says, graph traversal is ideal for security incident response because it can quickly trace password strength requirements, attack paths through roles and permissions, firewall configuration settings, or the octopus user login timestamps. So just tap your screen for which answer you think is correct based on what we were just discussing with our previous use case. And again, if you're just joining, feel free to hop onto the trivia scanning the QR code. We do suggest you sign on to the trivia using a different device so you can continue watching the stream as you're playing along. So you have 90 seconds, which now is down to about 40 seconds. And Melissa, what do we think about some of these options? Are there any that maybe you're thinking we could say, I definitely don't think it's this one?
So I'm going to call it the timestamps. So I think the aspect of temporality in graphs and representing time in graphs is it's something you can do, but depending on how granular those times are, how you plan on utilizing that time stream data, normally we prefer to kind of keep data in the data source that's a best fit for that. So anything really time-based, we like to keep it in like a time series type database. So
nice. Yeah. So time and graph. Not really one-to-one, or not one-to-one, but you know what I mean. Yeah. Okay, cool. So here we are. Question 1, the correct answer is attack paths through roles and permissions. So good job, everyone. The majority of us got it right. We're going to now hop into our next use case, but keep this open for the next question. We'll be hopping back to it in a little bit. So now
yes. Oh, sorry, Emma. I just wanted to add one more thing before we leave the security graph use case. So the last thing I wanted to mention about security graphs is for today's examples, we've really kind of zoomed in on the cloud security posture management use case, which is really about modeling different like cloud resources and how they can connect to each other. You can also think about security in terms of like other lenses For example, if we were looking at like more of a like a data lineage or like a library or a components type use case where maybe you've got certain software applications in your system that utilize and inherit other libraries and frameworks. Those libraries reference other libraries, and that there was a security vulnerability that affected one of those libraries, right? Having that representation in graph also lets you kind of trace back those paths of what is potentially affected and compromised. So when we're talking about security, we focused a lot today on cloud resources, but it's definitely extensible to really any situation where security and wanting to know if something's compromised, it's applicable to those situations as well.
Awesome. Yeah, I love it. I love how it's like it covers such like a broad range of things that like we don't have time to discuss in these 60 minutes, but just like there's so many use cases across like figuring out those relationships when an account or when a resource is compromised.
Absolutely.
Nice. Awesome. So I am seeing a few more folks joining us today. So we have people from North Carolina, Brazil. Welcome, welcome. This episode is our third episode in the Databases for AI series. Today, we're really talking about how you can determine if graph is applicable to your use case. And Melissa and I are walking through three specific use cases today. There are so many more that we just don't have time to talk about during 60 minutes. But so our next use case that we wanted to talk with you all about is fraud investigation specifically. So Melissa, in fraud, how can GraphRag help and like what problems is it solving?
Yeah, so the fraud graph use case is another very common use case that we see with graphs. And really, the way that we think about it is, for example, if you have certain account holders, and you can think of these as either credit card account holders or even like bank account holders, right? Like those holders of accounts, they might utilize certain attributes such as like emails or date of births, phone numbers, home addresses, things like that. So they'll utilize those attributes when they're opening those accounts. Um, and then there's a lot of different types of fraud that you can kind of pick out with a fraud graph. But the use case that we are really going to focus on today is potential fraud of stolen identities. So reusing certain attributes like your address or your date of birth or your email address, and seeing how those attributes are shared amongst different account holders in order to determine like that usage looks a little bit suspicious. Maybe I should dive deeper into that. And an example of this would be, for example, let's say we have a situation where we have multiple accounts that all share and they all use the same home address, but they each have different emails and phone numbers. So that of itself isn't necessarily suspicious because you could imagine that maybe it's just multiple people that all live in the same physical household. And of course, it's kind of natural for each person living in a household to have like a different email or a different phone number.
Right. Or
So
even
that
like
pattern's fine.
yeah, or even like me being in New York City, like there are so many people in my apartment building and we all have the same first line of address. I mean, we're not in the same apartment
Yes.
unit, but like our main address is all the same. So gotcha. That makes sense what you're saying.
Yeah, absolutely. And to kind of illustrate this as we go through, I'm actually going to share my screen and walk us through a demo just to show some sample data of what this looks like and also tie it back to agents. And so, again, really the goal of this stream today is to kind of help you all figure out in general what's a good use case for graph and how do I and how should I tie that back to agents to make the graph more accessible? So we'll be showing that through the demo that I have up on the screen. And everything that I show for this is going to be accessible We'll put the link in the description box so you'll be able to grab all the sample data and then run through this yourself.
Awesome. Yeah. So we'll pull up your screen. There we go.
Awesome. Thank you, Emily. So just to give a little bit of context before I dive into this, really what I'm going to be running through today is a sample Jupyter notebook. And so under the hood, I'm using what we call Graph Notebook, which is our open source package that extends the Jupyter magics, and it just makes it a lot easier to interact with Neptune. So Neptune is a managed graph database, and that's what I'm going to be using today to hold all my graph data. But the Graph Notebook is compatible with working with other graph databases as well. So we support a number of other open source ones, like BlazeGraph. You could do Janus Graph servers. You can even connect to Neo4j. So everything I'm showing today is going to be tied back to Neptune, but you absolutely have other options to use other graph databases and other local graph stores. All right, so I have already loaded my sample fraud data, and I am just going to set a few visualizations here, but just to give you a kind of bird's eye view of what this graph data looks like. So in general, if you're looking for, do I have a good graph use case? What I'm looking for is, first off, is your data highly connected? So is it full of many-to-many relationships? So we're going to validate that right now just by looking at some of the graph data that's in our graph. And I'm going to be using OpenCipher queries for this, but we also have other options available. For example, our open source Graph Explorer tool that will let you explore all of this visually with like a click and explore interface. But for this, it's just a lot faster to use queries for now. And so just to give you a little taste of what is inside this graph right now. So we talked about modeling a fraud graph in terms of like accounts as nodes, which we can see an example of one account here. And this one account happens to have associations with an IP address. So this is one of the attributes that we're choosing to model as a node. We've got home address, phone number. They have one birthday, which makes sense. And then they've also got a couple email addresses associated with them. So looking at this visual, right, we can see it looks pretty reasonable if you're just giving me.
Reasonable.
Yeah. Now, if we start to expand the view out more, and before we do that, I want to show you what else is in the graph. So we also have information about merchants. So these will be like different stores and storefronts, and these are treated as nodes. And we also have information about transactions, which are also treated as nodes as well. And you can see that these transaction nodes are actually associated back to certain attributes as well. So for example, these 3 transactions were made from this IP address, and that IP address is known to be directly associated to this account. So you can kind of infer that this account made at least 3 purchases, because I'm not showing the whole graph, but we can see they made at least 3 purchases at this merchant via this IP address.
Now that's so cool. Like as a visual learner, I feel like I just find this so interesting to look at. And there are so many different relationships. And yeah, I'm just like, I could spend not like all day, but like all day, like just like looking at everything and how everything is interconnected. So this is really cool.
Yeah, absolutely. And that is where the graph comes in, right? Because like to generate this view, you could get this conceptual view pretty easily just by looking at a table. You're like, okay,
Right.
account ID, the different columns for the different attributes. But once we start expanding out and like requiring multiple table joins to start to build out this highly connected view, that is really where the graph comes into play.
Yeah. Yeah, and just thinking about all the table joins that you would have to do gives me a headache, like, I'm like, "No." So I feel like this is so much more efficient also than, like, trying to figure out, "Okay, like, I have table A, and they need a left join on IP address and phone number," and yeah, so this is awesome. Much more efficient.
Yeah. Absolutely. And to kind of hit home on the table joins as well, right? Like here, in order to generate this, you could say, well, we only need maybe a handful of joins. Like it's pretty straightforward. We'll start to see that in some of these queries that we use. You're and I'll talk through them. I'll talk through the business logic, but you're going to find that you're not going to want to write a relational query to try to translate some of these. And that kind of hits home on point two, which, if we're talking more generally about what makes a good graph use case, we talked about point one is, do you have a highly connected data set, which we saw from the previous two visuals that we do, right? You can have accounts connected to attributes. Maybe those attributes are connected to other accounts, so on and so forth. So you have kind of these different layers of highly connected data. Now, the second point in understanding if graph is a good use case for what you're trying to do is actually the questions that you want your graph to answer. And so you could have situations where you meet point one, right? For example, let's say we do have a highly connected data set, like our fraud graph data set here. But what if the only questions I care about answering are questions like, get me all the accounts associated with this IP, or get me all the transactions that happened within a certain time period, right? Like those types of questions don't really require knowledge of how things are connected together. And so even though I would have a highly connected data set, I don't really ask any questions that require kind of those multiple hops across those connections. And so that's kind of that second validation that I like to use for a graph use case. So do the questions you want to ask require knowledge of how things connect together? And as an example of that, I'll talk through some of these graph queries and what they mean. If you're curious about the query language that I am using here, I am using OpenCipher, which is the open source subset of the Cypher query language. So it's actually a very declarative pattern matching type of query language. And you can see, as I'll kind of walk you through these, that they are pretty readable. And then don't worry, after the queries, I will show you the agentic part. So you don't have to write any queries at
Oh,
all.
good. I was worried.
Yes.
Do not fear. Do not fear.
Yes. So the first query is matching some logic that actually we talked about earlier about the shared household. So we're essentially picking out certain patterns where accounts will share the same IP address. And then for those accounts, we want to see like what other attributes are associated with those accounts. And so this is a query that'll pull back something that looks a little bit like this. So let me zoom in on one of these clusters. And this is an example of a connected pattern that is, I would say it's not very suspicious, right? It kind of makes sense because you've got two distinct accounts, same home address, same phone number. Back when we had landlines, I haven't had a landline phone since like maybe 10 years ago now, but I used to have one.
I only use it. I mean, I don't even use it. Only my parents have one, and I don't even use it. I feel like they only get calls from like solicitors, and
Yes.
I ignore that when I'm at their house. Yeah.
Yeah. Or remember when we all had one shared computer in the household? Everyone used the same computer.
Oh yeah.
Yeah.
One.
Yeah.
Now it's like everyone has their own laptops, and so many more devices in one home.
Yep. Exactly. So this query pattern, we're picking out some things that it's what I would consider not suspicious, at least for this cluster. If you start to see, a lot more shared connections between attributes that you wouldn't expect, like maybe like they're also sharing email addresses, like a lot of them. Maybe that could be a point of investigation that you'd want your fraud investigators to kind of double click on. But essentially, the premise here is having the ability to use graph queries to kind of pick out some of these highly connected patterns. Now, just to show you an example of what might be a little bit suspicious. So Let's say I have some account intelligence already, so I know that this particular account is a little bit suspicious. So what we can do is kind of start to zoom in here and see, like, basically what we're doing here is we're saying for this account, show me all of the attributes that are used by it. And then for each of those attributes, show me what other accounts are using those same attributes.
Oh, wow. So in other words, like we're using this one account that we know is or we think is suspicious, and we're saying, let's see everything that's related to this suspicious account.
Exactly.
That's so
Yes.
cool. That's so
And so
cool.
and so we can see that brings up this view of this little cluster where one of these accounts, let's see which one this is. Okay, so this is the account that maybe we got tipped off on that they might be a little bit suspicious. And then when we expand that view out, you can see like, okay, so they use this phone number, this birthday, email, home address, right? And then you can actually see like each of those attributes are also connected to a bunch of other accounts that share the same attributes as that original account, which
Yeah,
it's a little bit suspicious, right? Like
it is.
why does this person have so many different accounts?
Yeah. Melissa, actually, could we zoom in on your screen a little bit more, like Control
Yes.
Plus? Yeah, perfect. Thank you.
Yes.
And also, I just want to ask, so we got this really good question. Will the notebook that you're sharing, since it is such like a cool notebook, and I'm sure the audience might want to like play around with it, will it be available publicly?
Yes, absolutely. So there should be a link in the description box somewhere. If not, we'll make sure to add it. And that will be the link to download this notebook with all of the example queries. And it'll also just give you all the links to the sample data so you can play around with it yourself.
Oh my God, amazing. Thank you.
Yeah, absolutely.
All right.
Awesome. So before we get to the agentic part, I want to show one other thing in the graph, and then we'll jump to agents, so we don't have to worry about open center queries at all. So the thing I want to show is, for this example, this was great, right? Like maybe I had someone tip me off that this account is suspicious, so I'm gonna go and use my graph to kind of zoom in on that a little bit more. But what if you don't necessarily know where to look for the fraud first, right? Maybe I didn't get tipped off. I've got this big old graph, lots of connections, lots of data. Like, where do I even start to look in my graph to find potential suspicious activity? And so, one thing that is really nice about graphs is its ability to run what we call graph algorithms. And so this might take you all back a little bit to kind of your algorithms class back in college. But essentially, graph algorithms are kind of large scale graph queries that traverse the entire graph, sometimes even multiple times to converge on an answer in order to pull out some greater insights. And one thing that we see about fraud is that a lot of times, you know, the act of fraud isn't like a super common pattern, right? Like the act of fraud is actually a relatively small percent because most of your transactions are probably going to be legitimate things. And fraud is actually a very small percent. And it's kind of like looking for a needle in a haystack, so to speak.
It is.
And so one thing that we can do is we can utilize graph algorithms to kind of help us calculate insights to help us find kind of the outliers in certain graph patterns. And one example of this that I am showing is we're essentially wanting to find clusters of highly connected accounts and attributes, right? Because we saw earlier that something suspicious would be if you have like multiple different accounts that kind of share a few different attributes amongst each other, right? So what we're looking for is basically those clusters of highly connected nodes in the graph.
Gotcha.
And one type of algorithm that we could do for this is what we call the weakly connected components algorithm, which basically is one of many types of clustering algorithms that can kind of group together nodes that are highly connected. And so I can just run this query, which is essentially saying, for all nodes in the graph, which are either accounts or attributes, because that's really what I care about for this particular fraud investigation. We're going to calculate the weakly connected components and then write back the calculated cluster as a property. And so once we do that, we can actually take a look here. Oops, sorry, I forgot to run this previous cell. Essentially what I want to do is group. So I want to find out, like, for each cluster, like how many nodes are in that cluster, because that'll tell me the count of like how many accounts plus how many attributes are in it. And essentially the higher the number, the more highly connected that cluster is. And that is generally what would tip us off that something suspicious is going on.
Interesting. Yeah.
Yes.
Snooping out the sus.
Yes. So once we calculate that, this is just a histogram to show, like, for each community that we've kind of pulled together, like how many nodes are in it. And you'll see that there are some outliers here, which is exactly what we're looking for. So really the point of the graph algorithms is to help us kind of pick out the outliers in different graph patterns in our graph, which is what we've done here. And I'm just
Yeah, that's so cool. And I feel like outliers, like, and finding outliers can be applicable to so many other different use cases. And that's really what we're talking about today. Is the purpose of this episode is to figure out, is graph applicable to your use case? And so here's another example showing if you need to find outliers in your data, graph seems like the way to go. Would you agree, Melissa?
Yep, absolutely. And just to kind of prove that out, right? Like, I am going to grab all the nodes that we found in this particular cluster, because this is the outlier. It has the most, like, significantly more members in that cluster compared to every other cluster here. And if we take a look at that, we can see that this kind of generally matches the pattern that we were talking about earlier in terms of what we're trying to find, which is like the clusters of accounts that all tend to seem to share the same attributes, which can be a little bit suspicious. So we can see there's a high degree of interconnectivity here. There's a little bit here, as well as, if I zoom out a little bit, you can see there's some branch points here as well. And so the one thing to note about this is I would say, like, these algorithms and graph queries in general to help you pick out the highly connected clusters. It's definitely a great way to help you start the fraud investigation, right? Because then now I have a point to start looking, right? Like, I might not be that suspicious of these because, they're part of the cluster, but they're kind of isolated on their own, not a ton of shared attributes. But I would definitely start looking at this section as well as down here, where you start to see a lot of density of those connections.
Yeah, you definitely do see a lot more density down there, and that's also cool. Like, it would take me so much longer if I was looking at a table to find
Yeah.
this. Like, because it's so visual, I can, like, easily just be like, "Oh yeah, I'm seeing like a big group over there. Like, let's look into this." So that's awesome.
Yeah. I'm trying to even imagine how you would do this with tables. I guess you'd have to, like, join and then join and then join, and you probably want to, after you pre-calculate a bunch of joins, like, store it somewhere so you don't have to keep doing it. But then whenever the data changes, you got to recalculate everything because
Yeah, that
yeah.
just sounds like such a headache. So, graph.
Yeah.
We
Yes,
love it.
we do. All
Nice.
right. All right. So now, after I've shown you all the open cipher queries, we're going to talk about adding agents to it. And so again, kind of tying back to really the theme of today's stream being, how do I know I need a graph? And then where do agents come in? We've talked a lot today about graphs, and we've kind of looked through the graph data together. So, you might be thinking, like, yeah, I do have a good graph use case, but how do we actually make this accessible to end users? And I think that's where agents can come in handy for that, because there's a lot of great insights that we can get out of this graph data. But I don't want all my end users to have to know how to write a graph query in order to surface some of this information out. And so one thing that we can do is kind of add an agentic flow to this. And so I've already pre-built a lot of these. So let me run the application first and then we can talk through it.
Nice. And while that's loading, I see Trevor popping up in our comments. Is there a graph giraffe?
A graph giraffe.
Trevor, we missed you today. So, folks, Trevor has been on the last 2 episodes as a host, but unfortunately could not make it today. But he is here in spirit in the chat. So he'll be back next week.
That's awesome. Awesome. So I have a very simple Streamlit application stood up for this just to give us a nice little UI. But really, I would imagine this as kind of a starting point for like a little investigative dashboard that I could provide to my fraud investigators to kind of help them look into their fraud more. And so basically what we can do here is the user interface is basically you can ask any questions that you want, right? So for example, maybe I am starting my investigation and I don't have a starting point. So just tell me, go find me, agent, who has made the most transactions. Now, behind the scenes, how this is wired up is I am using the Strands SDK to build out agents, and I'm actually exposing a couple different tools to my agents, one of which is the Neptune MCP server exposed as a tool. And so if you're not familiar with the Neptune MCP server, it's essentially an MCP server that we provide that makes it really easy for your agents to connect to Neptune and then send a graph query. And so this is essentially where a lot of the magic happens because I no longer need to write OpenCipher queries. I can just have my agent, it's going to go figure out the OpenCipher query that translates to this question, and then it's going to go send it to Neptune, in my case, get an answer back, and then it can tell me that this account belonging to this person has the most transactions. Now we can take this a step further as well, and maybe I want to actually like see something. So I could do, for example, let's say, show me which phone number has been used by the most accounts. And now our agent is actually going to connect to and use our other tool that we've exposed, which is, I call it like a graph visualization tool, which is essentially going to help the agent figure out the correct path query in order to bring back the desired graph visualization nodes and edges in a certain format, and then we can pop that up on the screen.
Awesome. And Melissa, we do have one question. So I know we've been talking a lot about data and like the graph pulling data. So I wanted to ask you, is there a process of loading the data from transactional databases into Neptune as well? So this is one of our questions in the chat, and I think it's a really great question. I'm sure other people may have it as well. So
yes, absolutely. So I think depending on your use case, there are going to be different ways that you're going to want to get your data into the graph. So if we are talking about the use case where you're going to be ingesting structured data. So for example, this use case, this fraud use case, as well as the security graph use cases, your data sources are likely going to be living in some structured source for now. And so to get that data into Neptune, couple different ways. One of the more common ways is to set up kind of like a streaming ingestion pipeline from your source structure databases to go into Neptune. And the general architecture for that will look like you'll have like some stream or queue in front of Neptune. And then what you'll want is you either want events to get pushed into that stream. So these would be like a new add or a new delete happened on your source database. That event goes into the stream in front of Neptune, and then you'll have some client sitting between Neptune and the stream that's going to collect those events and then do the translation to the graph, right? So if you say like someone created a new account, right? So that's coming downstream in your system. Create a new account in our fraud graph model should be equivalent to add a new account node with all this metadata. And so that'll translate to the OpenCipher or the Gremlin query. That's like g.addv for Gremlin, account node, and then all this metadata. So you can certainly set up kind of these streaming ingestion pipelines to go from your source database to Neptune. In terms of, if we're talking about in terms of GraphRag, where you're generally working with unstructured data rather than structured data, depending on the framework you're using to build your GraphRag application, there's normally some type of document versioning process and method involved, so that if you are just like deleting certain documents or you're adding new ones or you're replacing a document with like a newer version, there's ways to kind of handle how you keep track of like the latest version and deprecate the previous ones. So sorry, that was a long way of saying, depending on if you're going GraphRag or you're doing just kind of standard like knowledge graph or like a graphy type use case, you'll probably have some type of streaming mechanism for like the standard graph use cases, and then use the document update processes for a GraphRag use case.
Awesome. Yeah, thanks for clarifying that.
Yeah, absolutely. Awesome. So there's a couple other queries that I can show here, but really this is kind of a base, I would say, that you can kind of start with to make the graph more accessible to end users. Another thing that I haven't built in here yet, but something that would be cool is, after you tell the agent, like, show me how one account connects to another account, have the ability to actually let people like double click on the visualization that shows up, and then it like expands the visual out. So it's like interactive while still having an agent helping you pull back certain information without needing to know any of the graph query languages.
Awesome. Yeah, thanks for sharing this. And again, this notebook will be available using the links that we'll provide in the chats as well.
Yeah, absolutely.
Awesome. So I think we'll transition then to the next two questions of trivia. So again, if folks are just joining us, feel free to join our trivia using the QR code in the bottom/middle-ish of the screen. So we'll be doing two more kind of like lightning rounds of trivia before we wrap up this episode. And again, this episode, if you are just joining us, has been all about use cases of graph. And so we talked about security incident response, and we were just talking about fraud investigations. So let's take everything that we've just gone over and test our knowledge with some fun trivia questions. So I'm going to click the next question. And again, recommend if you're joining to join the trivia on a separate device, and it won't be available if you're watching the replay. Just a heads up, but it'll work watching live. All right. So next question, graphs can detect fraudulent activities by identifying, is it the giraffe, multiple accounts sharing similar attributes, the duck, unusual transaction flows between seemingly unrelated entities, the monkey, suspicious connection patterns, or the octopus, all of the above? So Melissa, what are your thoughts about this? Let's hear your words of wisdom as you're reading through these potential responses.
Oh, graph giraffe. Absolutely.
Graph giraffe makes an appearance.
Yeah, so I'm thinking, a lot of these sound like they would be good use cases for fraud graphs and kind of things that you'd want to pick out with a fraud graph. I mean, I think as well, one thing to keep in mind is that like every organization is going to have a slightly different definition of what fraud is for their particular domain. So a lot of the patterns that we discussed today may or may not be actual patterns that a particular organization would define as suspicious. But I think that is part of the fraud graph development process. It's all about having, fraud investigators are going to describe in plain language what that fraud might be. And then you can translate a lot of that into the corresponding graph query to pick out what exactly that people are looking for.
Nice. Yeah. And so, like you said, and the correct answer is all of the above, which I could tell that you're kind of like, oh, well, none of them kind of stick out as wrong. So you didn't want to give it away. But yes, so all of the above are the correct answer. Graphs can detect fraudulent activities by those three options. So let's go on to the last question of the day before we wrap up today's episode. So, what makes account relationships difficult to analyze in traditional CRM systems? Is it the draft? Parent companies, subsidiaries, and people networks are interconnected. The duck CRM data is stored in the cloud. The monkey sales teams work remotely, or the octopus customer data changes too frequently. So, for this one, Melissa, is there any that sticks out to you as like, yeah, definitely not?
Yeah, so I know this question is kind of hinting towards a use case that we didn't talk about really in today's session, but really where we can start to see graphs kind of come into play for kind of like customer account intelligence is by being able to pull out data from your CRM. Maybe you've got some data living in other scattered systems like you've got a support ticket queue, you've got product usage, you've got a repository of documents that someone has been working on to try to tie back to the customers in your CRM. Right. So there's you can think of it as a lot of scattered data everywhere, but we want a way to kind of tie back all of that information into a single view and kind of understand the connections that might exist between like a company acquiring another company and then, oh, maybe like this person worked at this particular company. This person's part of this other team. So I know we didn't spend a lot of time talking about this particular use case today, but it kind of all comes back to those connections.
It does come back to the connections. And good job. Most people got this one right. It was parent companies, subsidiaries, and people networks are interconnected. The giraffe, I'm sure Trevor's like, nice, my giraffe. Coming into play. All right, so let's quickly look at the leaderboard. So congratulations to our top 10 and our top 3 who get medals. So, and thank you again, Melissa, for joining us today with that demo. I know our time is coming towards an end for today. So let's recap what we've covered. Hopefully now you can determine if GraphRag is applicable and useful for your use case. GraphRag can help you answer relationship-based questions like who knows, what's this connected to, and what's the path. So if you found this episode helpful, I think you'll find next week's episode super helpful as well. We'll be live on Thursday, February 5th at 12:30 p.m. Eastern. We'll be streaming from the AWS Twitch and YouTube for our 4th episode, and you'll be learning more about how your S3 data can make your AI smarter. So a few closing thoughts for today's episode. Download Melissa's notebook and play around with it yourself. If you're anything like me, I find like getting hands-on with data sets and concepts really help to solidify that knowledge in my brain. So that link to download her notebook will be available if you're on YouTube in the description, and then also in the chats if you're watching like on LinkedIn or Twitch. And the links, if you want to watch our previous episodes, will be available as well in the YouTube description or in the chats, depending on where you're watching from. So again, come tune in on Thursday, February 5th at 12:30 p.m. Eastern for our next episode of Databases for AI. And thanks again, Melissa, for joining.
Awesome. Thanks for having me.
All right. We'll see you all soon.